Today I would like to take up a question from class 12 integration, and I'm sure most of us have come across this question while solving the exercise on integration by parts. Now, taking a look at this question, integral e raised to 5x cos 4x dx. Now, usually I'm sure most of us will go directly applying the formula for integration by parts, and it's such a vigorous method, and it involves a lot of steps. It's quite difficult to solve. In fact, we will have to simplify it multiple times, leading to a greater probability of making mistakes. So a few days back I came across a fascinating method to solve this question using Euler's formula, which unfortunately has been deleted from our class 11 syllabus. Euler's formula is from complex numbers, and first let me write down that it's such a fascinating formula. According to from my point of view, Euler's formula is actually the most fascinating equation in mathematics I studied in class 11th. So e raised to I theta equal to cos theta plus I sin theta. This beautiful equation is Euler's formula. Now let me explain the terms. E is Euler's number, 2.71 something something something. It's a transcendental number. I is the imaginary number, that is root of -1. Theta is the angle made by the complex number in the Argand diagram. Okay, geometrical representation of complex numbers. I'm sure all of us have heard about the Argand diagram. Questions from it has been avoided in class 11th, but I'm sure most of us are familiar with the concept. Any complex number can be plotted on the Argand diagram, that is x, that is the real axis and the imaginary axis, and this angle theta is what is taken as theta in the Euler's equation. Now e raised to I theta equal to cos theta plus I sin theta. It's such a magnificent equation. It connects transcendental numbers, imaginary numbers, and cos theta and I sin theta, cos theta and sin theta when given values will give real values. So connects complex numbers, transcendental numbers, and real numbers. Now we will be using this equation to solve this integral. Now that I would like to discuss today. Now most of you might be wondering how we will use this equation to solve this integral. Well, we will take I equal to integral e raised to 5x cos 4x dx. Right. Now we will create another integral, another complex integral. Complex doesn't mean difficult, it means split into parts, just like complex numbers. So bear with me for a second. J equal to integral e raised to 5x sin 4x dx. I am just taking up this integral. You will soon find out why we chose this particular integral to solve the question. Now I am not interested in simply j. I would like to multiply it with the imaginary number I. So ij is what I am interested in, which will be, I will just rewrite it in some way, integral e raised to 5x I sin 4x. Right, e raised to 5x I sin 4x dx. Now what I am interested in is the sum of these two integrals, that is I plus ij, which is equal to integral, I will take e raised to 5x out common, times cos 4x plus I sin 4x dx. Now the beauty of this integral is that if you take its real part, now this is a complex integral and it contains the imaginary term I, you take the real part alone, you get I, that is capital I, which is our question. So the real part of this answer will give the answer to our question. Now again you might be thinking, why complicate it in such a long expression? This one was just 2 terms long. This was, again, we have expanded the integral. Now how do we go about solving this? The interesting part is that in this question, if you take I theta equal to cos theta plus I sin theta, notice cos 4x plus I sin 4x, this is exactly what e raised to I theta is. Instead of theta, you have 4x. Now, thus we can simplify this e raised to 5x into e raised to I 4x dx. Most of us know how to solve an exponential function, that is integral involving the exponential function. Most of us can do it mentally, right? Integral e raised to x dx is simply e raised to x. E raised to x function, that is exponential function, is not affected by the integral. So instead what we will do is, most of us can, and I am sure we can simplify this, e raised to 5x into e raised to I 4x. We can written as e raised to 5x plus I 4x, that is a raised to m times a raised to n is equal to a raised to m plus n. Yeah. So 5x plus I 4x dx. Right. So now we have created the complex integral I plus ij equal to integral e raised to 5x plus I 4x times dx. Let me write this down, sorry. So now solving this integral is quite simple. It involves no complexity. So you will come to e raised to 5x plus I 4x by 5 plus 4i. Right. Most of us know how to solve the exponential equation, so I am not elaborating over that, so that I don't consume so much time. So e raised to 5x plus I 4x by 5 plus 4i. I am ignoring the constant of integration right now. We will come to that last. Not necessary. Right now I am just focusing on this unique method of solving the question. Now we have to take the real part of I plus ij, which will give us I, which is the answer to our question. So in fact we should take the real part of e raised to 5x plus I 4x by 5 plus 4i. I am sure most of us know how to take, or most of us remember how to take the real part of a given complex number. Now we can simplify this a bit more. So e raised to, I will take x out common, 5 plus 4i times x by 5 plus 4i. Now to get the real part of this, I will probably do one more thing. E raised to 5x I can take out common times e raised to I 4x by 5 plus 4i. Now we can simplify this expression to get the answer to our question. So e raised to 5x, to get the real part, what we will do is we will multiply with the conjugate 5 minus 4i up and down, or probably I will write that too here, times 5 plus or 5 minus 4i, 5 minus 4i. Now this is simple. 5 square 25 minus 16 times I square is minus 1, so plus 16, 25 plus 16 is 41, so I can take that out common. So e raised to 5x by 41 times e raised to I 4x can be written as cos 4x plus I sin 4x, Euler's formula, remember. Now times 5 minus 4i. Now we want the real part of this, and that will give us the solution to our question. Now in order to get the real part of this expression, what we will do is e raised to 5x by 41 is real anyway. Now we have to simplify this. Now it's quite simple actually, straightforward. Cos 4x times 5 cos 4x, that's real definitely, since no I term is involved. So 5 cos 4x, and cos 4x times minus 4i will be imaginary. Again I sin 4x times 5 is again imaginary, no need to consider. And finally I sin 4x times minus 4i. I times I is I square, which is minus 1, it's real. So this is the last term we need. I sin 4x times minus 4i will be plus 4 sin 4x. I hope you followed. I will repeat it again. I sin 4x times minus 4i, 4 times I square times sin 4x. I square is minus 1, we have another minus 1 here, so minus and minus becomes plus, so 4 sine 4x, and thus finally we have come to our solution for the question, that is e raised to 5x times 5 cos 4x plus 4 sine 4x by 41. This is the solution to the given question. Now, most of you will be thinking this is such a long process, but that is only because I had to explain Euler's formula in the beginning, and that is why the video took 10 minutes. Actually, while doing this in an exam, unfortunately you cannot use this in CBSE exams since Euler's formula has been deleted from our class current portions. But in case it comes as MCQ or you are attempting some competitive exam, you will be able to use this method and you can probably solve this question in less than a minute once you are familiar with Euler's formula. So this is such a beautiful method of solving this question from integration by parts. Thank you.